Okay, we're going to solve a two-dimensional projectile motion problem. This is chapter 3, number 32. And in the problem, we're told that a rifle is aimed at a target 50 meters away horizontally, and it hits the target 2 centimeters below the aim point. What was the bullet's flight time? So first, let's draw it. I'm going to draw a target over here, and there's a gun. So, I don't know, there's a person. Here's a gun, and the distance from the gun to the target is 50 meters. And we're told that it's aimed horizontally, so the initial velocity, VI, is entirely horizontal. And we know that it's aiming here, but it hits here. And the distance in those two, the difference between those 2 points is 2 centimeters. It's 2 centimeters. So you're aiming in a straight line horizontally over the ground at something 50 meters away. You fire the gun, the bullet hits the target but 2 centimeters below the point where you were aiming. So what's happening is, while the bullet is traveling horizontally, it's also falling vertically, and it falls by a distance of 2 centimeters during the time it takes to get there. Part A of the question is, what was the bullet's flight time? Well, we're going to set this up with our standard set of kinematic parameters. This is two-dimensional motion, so we've got a horizontal motion and a vertical motion. For the horizontal, we know that we're going to be dealing with our usual set of parameters: displacement, initial and final velocity, acceleration, and time. We know that the horizontal displacement is 50 meters. The initial velocity we don't know. We know that the final velocity is the same as the initial velocity in the horizontal direction, because what's the acceleration in the horizontal direction? 0. There's no force causing it to change its speed in the horizontal direction. We're ignoring resistance. So the final velocity in the horizontal direction is just equal to the initial velocity in the horizontal direction. Well, that's not enough information for us to get the time. We know how far it traveled, but we don't know how fast it was going. What does the vertical motion look like? Well, in the vertical motion, we've got a vertical displacement, an initial vertical velocity, which I'll call VIY, a final vertical velocity, which I'll call VF, the vertical acceleration, and the time is the same between the vertical and the horizontal. It's just one bullet, so it takes it one amount of time to make its whole journey. The vertical displacement is 2 centimeters. I'm going to convert that to meters. That's 0.02 meters. Go ahead and write the meters up there for the horizontal so we remember that. Now, I can make this negative since it's going down. Then my acceleration would also be negative, minus 9.8. Doesn't really matter as long as they're the same sign, because the acceleration and the displacement are in the same direction. What's the initial vertical velocity? Well, since the gun is fired entirely horizontally, the initial vertical velocity is 0. The final vertical velocity, we don't know. It's however fast it's moving downwards after the short time it takes for the bullet to travel that 50 meters. And then there's the time. So in this case, I'm actually in pretty good shape. I've got a displacement, an initial velocity, and an acceleration. That's 3 numbers. I'm looking for the time. I don't even need the horizontal information in order to figure out the time it takes for it to travel. So I'm just going to look for the kinematic equation that relates the 3 numbers I know and the one I'm looking for. And that equation is y equals vi yt plus 1/2 ayt squared. In your book, it'll be written for horizontal motion, which is just x equals vit plus 1/2 at squared. So we're just writing that for the vertical component. So that gives us minus 0.02 equals, and happily, since the initial vertical velocity is 0, this first term drops away, and then we just have minus 1/2 9.8 times t squared, and that gives us the time is 0.02 times 2 divided by 9.8 square root. Okay, so we'll go ahead and get our calculator out and see what that works out to. 0.02 times 2 divided by 9.8, and the square root of that is 0.064 seconds. So that's the time it takes for the bullet to travel from the rifle over to the target. Part B then asks, what was the speed of the bullet when it left the barrel? In other words, what is that initial horizontal velocity? Well, now I know the time up here is 0.064 from part A. So I've got 1, 2, 3 numbers that I know for the horizontal motion. The fourth one I'm looking for is VI. The acceleration is 0, so we have a very simple relationship. The distance equals VI times t. The 1/2 AT squared term goes away, so that gives me VI equals 50 meters divided by 0.064 seconds, and that equals our initial velocity of the bullet, 50 divided by 0.064, and I get 780 meters per second.